Hi friends, today let's see how can we prepare aldehydes and ketones from different functional groups like alcohols, alkenes, alkynes, acyl halides, cyanides and also from hydrocarbons. This is one of the important topic in your lesson aldehydes, ketones and carboxylic acid for your board exam. It can come like complete the reactions or conversions. So learn always the starting and ending product like reactants and products and learn about the reagents. So don't by heart the reactions, you have to understand like what is in the beginning or what is a reactant and also what is a product. Accordingly, which reagent can be used in the conversion. So alcohols. First is about alcohol. Alcohols are the compounds with general formula like RCH2OH for primary alcohol, and for secondary alcohol it is R2CHOH. It means we will convert CH2OH to CHO if it is aldehyde, which is RCHO. And ketones are R2CO. It means CHOH, secondary alcohol. How can we convert that to CO? That is ketone. In alkene, C double bond C is there. How can we change this double bond to an aldehyde or a ketone? Similarly, in alkyne, C triple bond C. How can we change this triple bond to an aldehyde or a ketone? Acyl halide, RCOX is the general formula. How can we change this COX to an aldehyde or a ketone? Cyanide or nitriles, RCN. Cyanide is CN. How can we change that to CH or CO? Similarly, toluene and benzene, how can we change? So these are the things which I am going to discuss today. So let's start with alcohols. The first one is alcohol. So in alcohols, there are two methods. One is oxidation, another one is dehydrogenation. So dehydrogenation is the removal of hydrogen gas, we know that. So in oxidation, if you take primary alcohol, RCH2OH, we use an oxidizing agent. It can be PCC or CrO3. Then aldehyde will change it into, means primary alcohol will change it into aldehyde. CH2O, CH2OH will change to CHO. Primary alcohol to aldehyde. Similarly, when you take secondary alcohol, R2CHOH, use the same reagent PCC or CrO3. R2CHOH will change to R2CO, ketone. So understand like this, primary alcohol to aldehyde. Similarly, secondary alcohol to ketone by using oxidizing agents such as PCC or CrO3. Similarly, the same conversion can be done by using another reagent, that is copper powder at a temperature 573. They are also same, like CH2OH will change to CHO, aldehyde. Secondary R2CHOH, secondary alcohol will change it into R2CO, that is ketone, by using the same reagent. So two methods. So remember like what is in the beginning, what is it is changing into, and what reagent we are using. Number two. Number two is from alkene. Alkenes are the compounds with the carbon-carbon double bond. In this case, we use ozonolysis to convert it into carbonyl groups like aldehydes or ketones. So ozonolysis is very simple. Like if you take a simple alkene like CH2 double bond CH2, add ozone in presence of zinc, you cut the bond into two different parts like CH2, cut it into two half, CH2 double bond O. And on either side oxygen can be added. Here oxygen, here also another oxygen. So these are the two products, two major product, and the third oxygen will go with zinc oxide as a byproduct. CH2O is actually HCHO, formaldehyde only. CHO is a functional group. So we got two molecules of aldehyde. Like that, if you take another alkene like CH3, CH double bond CH2, same method only. Add ozone, you cut the bond into two halves like CH3, CH, double bond, then oxygen plus. One another half is there with another oxygen, double bond CH2. This is how we can write the ozonolysis reaction in a simple way. So the mechanism is different, like you have to write an ozonate like an intermediate and all. So I'm just telling some quick easy method to write the product. I hope you understood. Next is from alkyne. Alkynes are the organic compounds with the carbon-carbon triple bond. In this case, wherever triple bond is there, to change it into carbonyl group, you do hydrolysis, means hydration, adding water in presence of HgSO4, mercuric sulfate. In short, we can write Hg2 plus. So if C triple bond C is there, I'm just writing a simple alkyne like CH triple bond CH. Add water in presence of Hg2 plus. So by looking into Hg2 plus, always you understand that is by adding water to an alkyne. So water has H plus and OH minus ion. So OH will go here and H will go to the other side. It's symmetrical so that there is no change. If it's unsymmetrical, you have to follow Markovnikov's addition. So it is CH, one side with OH, triple will change to double, another side with the hydrogen, so it becomes CH2. After that, there is a rearrangement in the bond. Like double bond will come to the oxygen side, hydrogen from the oxygen will go to the carbon side. It becomes CH double bond, or double will change to single and become CH3. We got an aldehyde. It's ethanol, ethyne. This is ethyne. This that is to ethanol. If you take an unsymmetrical alkyne like CH3, C triple bond CH. So when you add water in presence of Hg2 plus, this time you follow Markovnikov's addition. OH minus will go to this carbon because that is the carbon with the lesser number of hydrogen. So CH3, C here the carbon with the oxygen and H, OH, triple will change to double and the last carbon with the CH2, one hydrogen. And there also the rearrangement like this. Oxygen will get a double bond and hydrogen will go to that opposite side. We get CH3, C double bond O, then CH3. Here we got a ketone. So in general we can say that if you are taking an alkyne like ethyne, we get an aldehyde always. If the alkyne is other than ethyne, higher alkynes always giving ketone. So remember, alcohol, alkyne, alkene. All these we converted into aldehydes and ketones. So these are the first three methods. Next is acyl halide. Acyl halide is the organic compound with the functional group RCOX. It means COX we need to change it into CHO. This method is only for aldehyde. We cannot prepare ketone. COX to CHO. By reduction only, this time we use another reducing agent like palladium in presence of barium sulfate. This reaction is called a Rosenman reduction. So this is one of the important name reaction in organic chemistry, the Rosenman reduction. Similarly, the fifth method is again RCHO only for aldehyde in this case, from alkyl cyanide or nitrile by using two methods. Either by adding tin stannous chloride in presence of HCl or by adding dibal H, diisobutyl aluminum hydride at us. So it's dibal in short. We change it into RCHO. So CN to CHO, CN to CHO and RCOX to CHO. In this, stannous chloride and HCl addition is called a Stephen reaction. So both Rosenman and Stephen reaction is only to prepare aldehyde, not to prepare a ketone. Got it? So the last one is from hydrocarbons. From hydrocarbons, especially we are taking toluene and benzene. See, in toluene, from toluene we can have three methods. First one is Ittard reaction. Toluene undergoes reaction with the chromyl chloride, CrO2Cl2, CS2 and followed by H3O plus, acid hydrolysis. See, instead of writing this intermediate, suppose if you forget to write the intermediate in the answer sheet, it's okay, fine. You can write this H3O plus along with this arrow mark and write this as the final product, benzaldehyde. So toluene to benzaldehyde. These three are the reagents. Chromyl chloride, CS2 and acid hydrolysis. That is Ittard reaction. Similarly, we can use chromic oxide, acetic anhydrides followed by acid hydrolysis. Similarly, here we can write H3O plus if you forget to write the intermediate. Then you write the final product as benzaldehyde. Or else by side chain chlorination. Again toluene, chlorine in presence of sunlight, you write H3O plus here. If you forget to write the intermediate, it's fine. You can write benzaldehyde as a final product. It means the intermediates are not that much important. If you are writing that hydrolysis product, hydrolysis step in the beginning along with the other reagents, it's fine. So it's olivine to benzaldehyde, three methods. Only one is having a particular name is called the Itard reaction. Another one, Gutterman-Koch reaction, which is there to convert benzene to benzaldehyde by using carbon monoxide, HCl, anhydrous AlCl3 or CuCl. Benzene to benzaldehyde. So these are the important methods which I said, like to prepare aldehydes or ketones from different groups like alcohols, alkenes, alkynes, acyl halides, cyanides, hydrocarbons like toluene or benzaldehyde. Toluene itself we studied three methods. One among that is Itard reaction. Acyl halide I said it's Rosenman reduction. From cyanide, one particular reaction is called a Stephen reaction. So remember the names of those reactions. It's easy to keep it in your memory. Let's see some questions to understand this concept a little more clearly. See propanol. Propanol to propanol. You see CH3, CH2, CH2OH is propanol. You have to understand like this. It is CH2OH. And in the product side, as per the question, it should be CHO, propanol. So CH2OH2 CHO by using chromic oxide or PCC oxidation. Similarly, pendant 2-ol. Pendant 2-ol is CH3CH2 CH2 second position with the OH. So CHOH CH3 2-ol. 2 on means this carbon will change it into C double bond. Left and right no change. CH2 CH2 CH3 pendant 2 on. You understand the change. It's secondary alcohol to ketone. Again we use PCC. Similarly here also butanol to butanol. Same PCC. You just understand which functional group is changing. 3-methyl butanol, all to on. Again PCC, secondary alcohol to a ketone. Butane, ine is carbon-carbon triple bond is there. On is having carbon with the oxygen, that's a carbonyl group. So in this case we can add water in presence of that in presence of Hg2 plus followed by rearrangement. So look into the question, see the functional group and you change or you understand the change. Accordingly, write the reagent. See here, COCl. By using palladium and barium sulfate do reduction, the COCl will change it into CHO in the product, which is ethanol. Those kind of reaction here. Stannous chloride and HCl, Stephen reaction. If you do Stephen reaction, the CN will change it into CHO, which is CH3, CHO, ethanol. Here also same only, we use diisobutyl, that dibyl. Dibyl it's only this one. So that CN will change it into CHO. Here also same, CN will change it into CHO. Got it? These are your textbook questions. So this is how we can understand the answers easily. No need to change the double bond in this. By using dibyl, only this CN, cyanide will change it into CHO. See, by using chromyl chloride and hydrolysis, I said now, here the first preparation which is Itard reaction. In this Itard reaction, we are using chromyl chloride. Wherever CH3 is there, alkyl group is there, that changes to aldehyde. So that change you understand and write the product. Here you will get the answer like benzene with NO2 no change. But that CH3 will change it into CHO. Similarly, here also the CH3 will change it into CHO because it is chlorination in presence of sunlight. Here COCl, palladium barium sulfate, which is Rosenman reduction. It changes to CHO. CN, dibyl, that changes to CHO. And here they said to find the reagent. This is Gutterman-Koch reaction. Gutterman-Koch reaction, benzene to benzaldehyde by using carbon monoxide, HCl, anhydrous AlCl3. Got it. So like complete the reaction, you just understand the last part and write the reagents accordingly, or by using the reagents you can write the product. Okay, so complete the reactions or conversions. Any question can be answered if this concept is thorough with you. So I hope you understood. Thank you all.